Hey, it's 10 o'clock here in the Netherlands, so we'll start. Hello, everyone. My name is Erik Nijveld, co-founder of technologycatalog.com. Most of you on the call are likely already familiar with technologycatalog.com. For those of you that are not, I would encourage you to have a look. The platform already contains over 500 technologies to improve performance. The title of today's webinar is Reduce the Cost and Risk of Plugging and Abandonment of Wells. It will be delivered by Torger Skillingstad, chairman of Exedra, and Bernt Pedersen, co-founder and CEO of Exedra. The webinar will last about 30 minutes. If you have any questions, please type them in the Q&A box on the left-hand side. The webinar will be recorded. You will receive a link after the webinar and feel free to share the link with your colleagues. And I would now like to hand over to Torger. Torger, over to you.
Thank you, Erik. Thank you for the introduction. So everybody, thank you for taking the time to listen to this webinar. My name is Torger Skillingstad. I'm the chairman of Exedra, and I'm today going to tell you about technology that will help the oil and gas community to reduce their costs and also reduce the risk of plugging and abandonment offshore wells. So with that, I will start my presentation. So well abandonment in the North Sea or worldwide is a huge task, and it will cost a lot of money. So just for the North Sea itself, and this is data from ONG UK, Oil and Gas UK authorities, there's about over 2,600 wells to be decommissioned in the North Sea in the next 10 years-ish. And the P&AA, the well cost of that decommissioning, accounts for approximately 50% of the total cost. So that is estimated then with today's number to be over 120 billion Norwegian kroner. So it's a huge cost, and the authorities, operators all want to try to reduce this cost, because in addition, when you look at forecasts for additional wells to be drilled until all the lights are closed for oil and gas extraction in 30, 40, 50 years, the total number of wells and projects that needs to be abandoned will be even 4 or 5 times the above numbers. So it's a huge task, and it will cost a lot of money. So there's a huge drive from the operator side, from the authority side, to take down this cost, and at the same time make sure that the wells are plugged safely, that they are tight for eternity, that there's no leaks of environmental gases, hydrocarbon gases out of the wells. So with that in mind, Exedra was founded in 2016 by Bernt Pedersen. And he saw this need in the market to be more efficient, to be more accurate in how you plug your wells, and to better make sure that you know that the final barrier plug is leak tight. So you all know that today's method of checking if a final well plug is leak tight is to more or less just pressure up on the standpipe with the rig above and monitoring to see if the pressure starts leaking off. That's not an accurate method. We all know it has some shortfalls, and therefore there is a need to try to see if we can do it better. And Bernt came up with the idea to use a well-known method from the process industry. Basically, inject tracer gas, pressure up from below the plug, and then sniff above the plug to verify if that gas and fluid leaks through the plug. So it gives you an ambiguous results. You test in the right direction from the environment to the external environment. That's where you want to check is no leak. It's not the opposite. You don't want the pressure from above into the reservoir. It's actually when the reservoirs are actually filled up with high pressure carbon material that you want to make sure that the plug is leak tight. So the system, we call it BALDER. It's a downhole tool. Today's prototype and commercial offering is for typically 9 and 5/8" plugs. So it's 5-inch OD, 2.5 meter long. It's rated to 130 degrees Celsius, and it has an onboard tracer gas filled up to 7,500 psi. It has a pin thread, and it can be connected to any oil fill equipment. It's typically deployed on a standard bridge plug that is used as the base for the final permanent well barrier. And then when you have run and completed the plugging operation, even if it's dumping a cement or if it's perforation cement or if it's more exotic materials, then the tool, which will be pre-programmed and downlinked to from surface using pressure commands, will then wait until the barrier has sealed and cured, and then it will start releasing gas to a certain pre-programmed overpressure of the static pressure in the well, and try to see if it can penetrate through the barrier. If you have a rig on location, you will be on top of the plug with a drill bit, and you will circulate bottoms up. So instead of doing the pressure test, you will basically circulate bottom up. You will sniff on surface using standard hydrocarbon modeling and monitoring systems, as you can see on the picture here. And if you sniff the tracer, you will then know that you have a leak. We can also more or less determine the leak rate so that you know what to do to rectify the failure. So it's extremely sensitive, it's very low cost, and it has a very quick response time. So with that, we allow the operators to basically use new material, shorter barrier, new technology to reduce the cost, but at the same time make sure that the barrier is leak tight. So it will allow the operators to try new technology, to use creeping shale, test creeping shale, dual PVC casing, shorter plugs like bismuth alloy barriers, and at the same time ensure that they're leak tight. We have had communication with authorities on the North Sea basin, and the authorities, we have a quote from authorities saying that it's better to have a short but verified leak tight barrier than a long old-fashioned cement plug that you haven't ensured is leak tight because today's method of testing it is not accurate. So with that, I'm going to leave it to Bernt, the founder of the company, to give you an update on the status of the service and technology.
Okay, thank you, Torger. So I'm Bernt Pedersen, the founder of the company, and I've been working in the oil and gas industry for 30 plus years, amongst others as a technology manager in Shell International. So yeah, this slide shows the current status and the milestones we have achieved so far. Going through it briefly, in first half of 2019, we secured the funding of the technology development from operators, the Norwegian government and private investors. So we have funding from Equinor, Aker BP and ConocoPhillips. We tested the concept at the Norwegian test rig facility Ullrig in the fall of 2019, where we demonstrated the principle and an extreme sensitivity. We detected easily down to 1 part per million in terms of leak rates compared with flow rate of the drilling fluid. We did the mechanical and electrical design prototypes 1.0 during the fall of 2019 and 2020. We then tested it at the same test facility in the fall of 2020. Based on that, we did a number of engineering changes and designed the prototype version 2.0. This production was finalized last fall, we now have 4 prototypes on the shelf ready to be deployed. This prototype was tested and qualified very rigorously, as I will show in the next slide, and we demonstrated an extremely high reliability of the system. And then the last milestone is demonstrating the technology in an offshore well. And in fact, I'm going offshore now Friday this week to demonstrate the technology at the Gullfaks field for Equinor. Next slide, Torger.
Sorry.
So this, So we have qualified the technology very rigorously, both using redundancy and in the design, and also going to extreme measures with regards to the qualification. It is fully tested according to advanced well equipment standards, which is originally a standard made for MWD equipment. We have also used DNV throughout the development and qualification process. So they have reviewed all our testing plans and then all the test reports and conclusions we have drawn. And we have used their technology qualification standard RP 8203, which is a very much used standard for technology qualification in the oil and gas industry. It has been tested extensively, both the dual coil valve, which is protected by double check valves, up to 130 degrees centigrade, 7,500 psi differential pressure. So we tested the valve 115,000 cycles with full pressure and temperature without any leak whatsoever. We tested also the electronics very rigorously using highly accelerated live testing, where we tested 4 boards to an elevated temperature of 155 degrees for 55 days without any hiccups, no failures. We also conducted shock, vibration, and temperature cycling testing at the Kiva test facility in Kongsberg. This is a test facility for the defense industry for testing and qualifying missiles and torpedoes. So they underwent extreme shocks and vibrations, and where they fully qualified the tests. So we also got some assistance to calculate expected reliability using statistical methods. So we calculated the reliability to better than 99% at the system level. Next slide, Torger. Yeah, so this is actually the tool attached to big hex plug from Interwell, which is the assembly we're going to run now at the Gullfaks C field this coming Friday. And the business rationale for Equinor is using this technology to qualify their PWC barrier, because today they are using a very time-consuming procedure where they drill out, they set the PWC, drill out the cement, run an acoustic log, and re-cement the barrier. Using our technology, we will eliminate this verification and simply place our tool below the PWC barrier to be tested. And then when they dress off the cement at top, if they do not sniff any tracer gas molecules, they will then conclude that the barrier is leak tight. And they are using, as Torger previously mentioned, they are using the standard already installed hydrocarbon detectors. It's a standard flame ionization detector, a gas chromatograph, which is installed on most facilities, at least around the North Sea basin, anywhere. So there's no additional costs on the detection side. Yeah, I just want to mention this is just one application amongst many. So yeah, we can see that on the next screen. We have also we have a collaboration with a UK-based consultancy, Astrimar. They have developed what we call a leak, well barrier leak estimator, where the operator can input all the geometry for the barrier, the length, dimensions, type of barrier, whether it's a casing barrier, section milled, analyse barrier, PWC, or a dual casing. And based on the type and the geometry of the barrier, calculate the and also they will then calculate the expected breakthrough time in case there is a leak, and expected flow rates, leak rates through the barrier, depending on what the effective microannulus might be. So this will help us both to plan the job, but also to interpret the results from potential leak. So it will be possible to actually quantify the leak rates. Yeah, I think that's it. Huh?
Yeah, so I think this was the last slide we wanted to show you. Like Bernt said, it's for a wide range of applications. I think the fantasy and the creativity of the oil and gas environment, the P&AA environment, needs to try to use it as best as they can, but it can also including being used for rigless operations. So it's definitely a tool that an operator, a service company who wants to design an P&AA barrier can use to get down the cost of sealing the well, but at the same time ensure that they have verified that the barrier they place in the well is leak tight.
Yeah, and we, as Torger also previously mentioned, we have been in dialogue with the regulators, both in Norway and the UK, in the Norwegian Petroleum Safety Authority and British UK, HSE UK, and they both have expressed willingness to accept deviations from existing standards and guidelines, given that the operator will mitigate their risks by using such a type of technology. So we think this will open up the possibilities for the operators to introduce more cost-effective plugging solutions, such as shorter barrier, shorter section milling, shorter PWC, rigless abandonment, using bismuth, short bismuth plugs, for instance. So we have been in dialogue with 3 technologies delivering bismuth plugs, and they are all very eager to test and verify their barriers using our technology.
So with that, we open up the table for questions on the technology, the service.
Anyone indeed in the audience can type in questions in the Q&A box on the left-hand side. To start with, one question from my side, and many thanks for this insightful presentation. And are you actually working together with solution providers of novel plugging solutions, as your solution can be an enabler for novel solutions?
Yeah, so we have agreements with some providers of barriers, both the integrated company and also providers of the barriers itself. So it's natural for us to integrate our solution with the providers of the permanent barriers, such as the providers of PwC barriers.
So, and our aim is to have this technology as seamless as possible. So if we are joining with a service company that are actually placing a barrier, being a PVC company, then we will aim to train their offshore operators to use our tool, program it, attach it to their bridge plug or whatever we will deploy together with, so that we don't even need to have staff offshore. And as Bernt mentioned, the detection system is the standard hydrocarbon detection system that most rigs have when they are actually in a scenario where they are having hydrocarbon fluids that can come to surface.
Thanks for that. Are you actually at this stage also looking for trial candidates in other countries besides the ones you mentioned?
Yeah, absolutely. So we have been in dialogue with some possibilities. So we would very much appreciate if there are trial candidates, either onshore or offshore. If it could be onshore in the Netherlands, for instance, or in the US, that would be great. But also offshore in the UK sector of the North Sea is of interest. So absolutely.
Great, because indeed in the audience there is certainly, I see people from the Netherlands also linked to the next step activities here in the Netherlands. But I also know for sure, yeah, given all the activities in, for example, Australia, that could also be a great target for your solution.
Mm-hmm.
I see a question coming in from the audience. Let me read it out loud. Hello, thanks for presenting 2 questions. How do you confirm? 2 questions. How do you confirm the gas is released below the barrier? And the second question, how do you confirm the gas flow goes through the annulus and between brackets dual casing remediation by perforations above and below? And this question comes from Frank de Milk, and P&AA team lead in Shell.
Okay, yeah, so I can answer the first question. It's a very good question, and in fact, that was discussed in length with the operators when we started the project. That's the reason why we have gone to such a length to demonstrate the extreme reliability in the system, and we have used redundancy in the design in just about in every component except the main CPU. So we consider this has to be sort of like the warning system you have in the car for your braking fault warning sign, or airbag, for instance, a system that you must know, you must trust it before you deploy it. Another mitigating effect is that we have programmed the tool to inject a small amount of gas. We call it a calibration signal, which is released right before the plug is set, and that tells us that the tool is working as it should. And then we have a very last signal, which is released with the gas, which tells us that now the clock has started ticking down towards when the gas is to be released. So the chance that the system will fail after it has injected these 2 signals, and then when it's supposed to release the gas after the barrier has been cured, we regard that risk as extremely low. So that's and then also we will provide also a downlink option where we can actually program the tool, and then the tool will respond with an acknowledged call it signal, a gas that will be released right before it's set. So it's we regard this risk to be extremely low. And the second question you had was how to ensure that the gas will actually re-enter the fluid column instead of just continue to travel outside of the casing, if I understood you right. And you can see on the slide well barrier leak estimator, the picture on the right-hand side, that we will perforate below and above the barrier, so that we ensure that there is a potential leak path in case there is a leak across the barrier. This transfer gas will then re-enter the fluid column above the barrier.
Thanks, Bernt, for addressing that question. If there are any other questions from the audience, please type them in the Q&A box. And I see a response from Frank. Thanks for answering. Follow-up question. What is the time frame between the gas being released and you can sniff the gas after the cement has been set? Is it straight after or is it days after?
Okay. We have done some preliminary tests using a real 9 5/8 inch cement test items, only 2 meters long. Based on that and some modeling, we assume that we are talking for a standard 50-meter long cement test. We assume that we're talking in a range of maybe less than an hour, definitely not days, that's for sure. But this estimator will also help us to estimate these what we call breakthrough times more accurately.
So as Bernt mentioned, in those tests, the operator also wanted to rule out that when there was a failure in a bad cement job, microannually between the cement and the casing, that it wasn't failing easier with the gas being pumped through, rather than if you have a real live well where you have hydrocarbons in the well, and it was proven that it's really the fluids you need to push through the microannulus. So it's the forces of the fluid, the capillary forces and the drag forces and the viscosity of the fluids and the differential pressure over the microannuli and the length that determine, if it will fail and fluid will go through with the tracers, or if it will be leak tight. And that is all incorporated into this calculator. So you can actually, in the calculator, simulate different microannular failures and see how big they have to be to actually, with the given delta P, differential pressure you push across the barrier, how big they have to be before you get the failure, and then it will calculate the time it takes to actually break through the failure. So we will, of course, use that in our estimation of when we circulate and finish the circulation on top of the barrier.
Excellent. We have a question coming in from the UK. Great game-changing technology. Could BALDER also be set below a sonar isolation plug to confirm there's no microannulus, which could also allow future water breakthrough?
Sorry, can you please repeat the question?
Let me repeat. Great game-changing technology. Could BALDER also be set below a sonar isolation plug to confirm there's no microannulus, which could allow future water breakthrough?
Yeah, it can be used to verify any barrier. It doesn't need to be a permanent well barrier that you set for final P&A. It can be any barrier. So it's the creativity of the industry that can use this technology to verify, better, more cost-saving technologies.
Excellent. Actually, one final question before we're going to close the webinar. Given the strict technical requirements in Norway, is your expectation that the moment you've demonstrated this in Norway, that it would quickly open the door towards other countries, or do you foresee that you do need to do trials in multiple countries?
Okay, I can try to answer it. We see that the Norwegian standards, such as the guidance D010, is used in several oil and gas provinces around the world, but we see the market as quite fragmented. Some areas they have very strict environmental concerns, whereas other areas in the world, it's very much up to the operator and much more relaxed regulations. So we see this will vary a lot around the world.
But Eric, as we see the technology used together with a new way of plugging the well, we don't see that we will be used in a standard 50-meter section milled cement plug scenario. We will be used when they actually come with a new way of doing it, and they need to verify it better to get approval or to ensure themselves that this new shorter plug, for example, works. So because of that we believe that we will be used with new ways of plugging the wells. There will definitely be a lot of field tests in new regions. You know, if an operator wants to try something new for offshore West Canada situations, I'm sure that the first deployment they will field test. They will not basically widely implement new technology without trying it out first, you know, and verifying it works. So definitely we see that we will field test in each country the technology, get the confidence that it works in combination with the sought and decided barrier, correct, that they wanted to try it with.
Excellent. Well, thank you very much, Torger and Bernt, for presenting this and very interesting, great technology. So I would like to hereby close the webinar. The recording will be made available. And if you have any other questions to Torger and Bernt, please follow up with them directly. Thank you very much and wish you all a great rest of the day or great evening. Bye for now.